Hi everybody, and welcome to another Informatica Cloud webinar. This is a very exciting webinar for us. We're excited to have our partner from Amazon here to really take us through what has become a super hot topic and a super hot product for Amazon. And I think that's reflected by the number of you on today's call. So we've got Rahul Pathak here from Amazon Redshift. We've got Nicholas Brazou, who's going to be taking us through a pretty deep Informatica Cloud demonstration of our connector for Redshift, and we do want to take some questions and answers as we go through today's session. So an action-packed full agenda. Here you can see what we're going to be going through, and I think we should just dive right in. So before I hand it over to take you through the Amazon Redshift product line, I wanted just to quickly set the stage. Many of you on today's call are familiar with Informatica. Informatica is a publicly traded company. We've been in business. This is actually our 20th year in business, so an exciting year for our company. And we're really proud of some of the success we've seen in the market, and really that's reflected by the customer success that many of you on today's call have experienced with our technology. So I just wanted to set the stage with a brief overview of Informatica. If you are new to who we are and what we do, just a little bit of background on the company. Today's focus is really going to be on what has become our fastest growing product line, which is Informatica Cloud. And we're going to specifically talk about the new cloud integration we've developed for Amazon Redshift. If you want to learn more about Informatica Cloud, you see our URL there, informaticacloud.com. And in fact, if you're a multitasker, you can go and actually sign up for a trial and start playing around as you're listening to today's session. So just a little bit of background on Informatica and Informatica Cloud. And in terms of our partnership with Amazon, early this year, in February in fact, we announced a pre-release of our Amazon Redshift connector. And we're excited to say that that is now generally available to our customers. And again, if you sign up for a trial in Informatica Cloud, you can actually start to work with it and see it for yourself. And you can see the URL for that there. So with no further ado, I'm going to hand it over to you, Rahul, to really take us through Amazon Redshift and help us understand why it's gaining so much interest and traction in the market.
Excellent. Thanks very much, Darren. Appreciate it. And thank you, everybody, for joining. It's great of you to come here today, and looking forward to telling you about Redshift and also why we're excited about our relationship with Informatica and how you can make the most of both of these products together. So just to give you a little context, Redshift is the newest managed service from AWS Database Services, and so we provide fully managed services that automate a lot of the muck and undifferentiated aspects of running large-scale databases for OLTP, caching, NoSQL, and now data warehousing. And with Redshift, what we set out to do was to build a powerful petabyte-scale data warehouse that was significantly faster. Our internal goals were 10 times faster than row-based stores for analytic queries. That was a lot cheaper than what's available today, and we also wanted it to be really easy to use. And with most things at Amazon, the reason that we created Redshift was that our customers asked us for it. They wanted a way to do data warehousing that was easy to provision, didn't require hundreds of thousands of dollars or more spent up front or weeks to get up and running. They didn't want to have to pay. They wanted to be able to pay as they went, and they wanted something that was fast, cheap, and easy to use. And we wanted to produce something that would work with customers' existing tool chains, and so that meant SQL from our perspective. And so what we see is customers using Redshift in a range of use cases. There's traditional data warehousing, which is you're all familiar with. And here we've seen a lot of interest in reducing costs by using Redshift to extend their data warehouse rather than having to add hardware on premises. We've also seen customers interested in migrating off legacy platforms. And in general, the main driver here has been the ability to respond faster to business and to be able to provision and get up and running quickly. We've had a customer start laughing when I told him he could provision a data warehouse with terabytes of storage in 15 minutes and get up and running relative to what they'd been used to in the past. It was a pretty big departure. We've also seen, in addition to enterprise data warehousing, a lot of big data use cases where customers are interested in combining data from things like device logs, web analytics, and then merging those with their relational data sets so they can analyze them in one place. And here it's been about accessing business data quickly, high-performance data warehousing, and providing SQL access to their analysts so that they can query data in a language they're already familiar with. And another area where we've seen a lot of interest is SaaS companies, people providing software as a service, looking to embed analytics and reporting and dashboarding into their own applications that they then deliver to other customers. And here, Redshift scalability and ease of ability to grow as customers' needs grow, as well as performance and low cost, has been a big factor in its adoption. And I'll talk about all of these elements as we go through here. And just a little update, we launched Redshift on Valentine's Day this year. No one on the team had any plans that night, so it's been the fastest growing service in AWS history. We announced 10 weeks into it, over 1,000 customers adding over 100 a week. And we obtained our SOC 1 and SOC 2 compliance certifications, and actually just this week also obtained PCI, so spending a lot of effort on security. And we've been rolling out globally, so you can now deploy Redshift data warehouses on both coasts of the US, in Europe, and in Japan. And we plan to roll out to our other regions worldwide as quickly as we can. And just want to tell you a little bit about how some of our customers are using Redshift. So Airbnb does short-term room rentals. They've seen dramatic speed up in query times as well as cost reductions. And they've actually been using Redshift in place of some of their Hive workloads. Accordant Media is a real-time ad bidding platform. They have to respond to display ad auctions by choosing and placing an automated bid and then serving an ad if they win, all in under 200 milliseconds. And they've been able to use Redshift to dramatically speed up their iteration time on developing their models to decide how much to bid for a particular spot. And then you have companies like Nokia who are migrating from their existing systems and seeing significant reductions in cost as well as improvements in query times. And you'll see this theme of price and performance and ease of use come up over and over again. So Bitly is a social link sharing and analytics service. And for them, they've been able to query billions of links and customer interactions in times that just really weren't possible for them with what they were using before. HasOffers is mobile app optimization, and this is an area that's exploding as well with all of the interest in mobile devices and tablets. And again, here it's about query performance and the ability to iterate and develop better analytic models more quickly. And Infor is the world's third largest ERP vendor, and they've got 70,000 customers worldwide, and they announced that they're integrating Redshift into their SkyVault product, which is an enterprise analytics product that does analytics on data flow within the enterprise, and they're using Redshift under the covers to provide high-performance, low-cost data warehousing to their customers. And so I talked about trying to get 10 times the performance of row-based stores, and I want to dive into a little bit about how we do that. So one of the first elements is Redshift is a relational data warehouse, and it's columnar. And so what that means is data is stored individually in columns. And so if you look at the table on the right, when you're using a row-based data store, if you wanted to get, for example, the average amount across your entire data set, you'd have to read every single column of every single row and then throw away 3 of the 4 columns to get the answer that you want. And so you end up doing a lot of unnecessary I/O. Whereas with a column store, what happens is because the columns are stored independently, you can just read the column that you want, and in this case you do a quarter of the amount of I/O that you would normally do. And because analytic queries typically operate on a subset of the columns in a table, you can see massive performance gains due to I/O efficiency. Another aspect of columnar technology is you get better data compression because similar values are stored sequentially on disk. You're able to compress them, which leads to more I/O efficiency because anytime you read, you get more data. And Redshift actually samples your data when you're loading it and automatically picks the best compression mechanism for each column independently. And so what you're seeing on the right of the page is the output of an analyze compression SQL command, and it shows you each column and the encoding that's picked. You have full control over this, but in general, Redshift will do pretty well automatically. Our customers typically see anywhere from 4 to 8x savings across real-world data sets, although naturally some columns will compress much, much more than others. And so what this means is that you can fit, if you get 4x compression, 8 terabytes of data into a 2 terabyte Redshift cluster. Another technique for I/O efficiency is zone maps. And so what we do here is keep track of the minimum and maximum value in any block for all columns. And for sorted columns, this allows us to skip over blocks that don't contain the data needed for a given query. And again, the theme here is we don't want to do reads unless we absolutely have to do them. But we know that at some point we're going to have to go to the disk to get the data. And so when we do that, we want to use direct attached storage rather than network attached. And the goal here is to maximize throughput. And Redshift runs on a hardware platform that's optimized for high-performance data processing, and I'll talk about the details of that in just a second. Another technique that we use is we use large data blocks, and these are compressed, as we discussed. And so every time we go to the disk, it's a direct pipe. We get large blocks, and those blocks are compressed, so we get as much data as we can when we are in a position when we have to do reads. So the other aspect of performance is Redshift is a massively parallel processing MPP system, and so we try and do as much in parallel as we can. And so what you're looking at here is a leader node, which is a SQL endpoint. You can connect to it using JDBC and ODBC, so standard SQL and BI tools will work just fine. Folks connect R or their own applications to the leader node. The leader node is responsible for coordinating query execution across the cluster. It actually generates and compiles C++ code when you issue queries and then executes that in parallel on the compute nodes. And the compute nodes are where your data is stored. They have spindles, local spindles on them. They execute the queries, return results back to the leader node where they're collated and then sent back to the requesting client. And everything in the cluster is interconnected in our high-performance computing or HPC network. And that's 10 gig E non-blocking fully bidirectional interconnect, so a very high performance interconnect between those systems. And the nodes themselves can be, they're connected to Amazon S3, which is our block storage designed for 11 nines of durability. And there you can load data in parallel with a single SQL statement. And we also automatically back up everything in the cluster to S3. And although Redshift is designed to be run in a clustered model, we do provide a single node version so you can fire up a cluster for under $1 an hour, and I'll get into the details of our pricing as well. Our hardware platform is optimized for high-performance data processing. We have two sizes. There's a high storage 8 extra large, and this one has 128 gigs of RAM, 16 cores, and 16 terabytes of compressed customer storage. And that's across 24 spindles. So you see over 2 gigabytes per second scan rates on this system. And then we make available as well a imaginatively named single extra large, which is 1/8 on all dimensions. So 16 gigs of RAM, 3 spindles, and 2T compressed. And so what that means is if you had 4 to 1 compression, you could store 8 terabytes of your data on just a single node system. And the 8 extra large is available on Amazon EC2 if you want to run your own applications and take advantage of that hardware platform. And with Redshift, we designed it so that you can easily scale up from a single 2 terabyte node all the way up to 100 of the 8 extra large nodes. So you can go from 2 terabytes to 1.6 petabytes of compressed data, and you can resize while remaining online for reads. And that's an operation that we make straightforward in the cloud. It's not so easy to do when you have to wheel racks around. What we actually do is spin up a brand new cluster in the background, do an automatic parallel node-to-node copy of your data, and then move your SQL endpoint onto the new cluster and tear down the original one. And so talking about pricing, that was another area we really wanted Redshift to be priced in a way that allowed customers to really process all of their data. We didn't want them to have to decide whether or not it was worth analyzing the data. It was just more of a decision about whether or not they wanted to do this. And so we offer 3 ways to price Redshift. What you're looking at here is the pricing for a single extra large node. So you can buy it by the hour rent it by the hour for 85 cents an hour. Then that translates to an effective annual price per terabyte per year of about $3,700. And that's inclusive of hardware and software. There's no additional costs. And then we also have a reservation model where you can essentially commit to a 1-year or a 3-year term. And the 1-year term gets you a 40% discount, and the 3-year term gets you over a 70% discount, bringing the pricing per terabyte per year down to under $1,000. And the 8XL is just 8 times this on the hourly rates, but because it has 8 times the storage, your cost per terabyte per year is exactly the same. And the pricing model is simple. We don't charge for the leader node. It just depends on how many nodes you're running in your cluster and how many hours you run them. And then the final aspect behind, I think, Redshift's adoption has been really ease of use. And so what we've tried to do is design a system that allows customers to access large-scale, high-performance, best-of-breed data warehousing technology in a very simple way. And so we've made it easy to provision. You just have to fill out a simple web form, choose the region you want to deploy in, and within 15 minutes you'll have the cluster of your choice up and running and a SQL endpoint that you can then plug into your applications. We've also invested in our console to provide you with a management interface where you can see which queries are running, look at their explain plans, see how many resources they consumed on the cluster. We've resized, we've talked about, made it simple to scale up and down. And then we've also made securing your cluster and daily operations straightforward as well. And so from a security perspective, we talked about our SOC 1, 2, and PCI compliance, but we provide SSL capabilities so you can secure your data over the wire. We also enable easy encryption of data at rest, and we use AES 256 hardware accelerated encryption, and this is just an option in the console that you can turn on. And once you enable it, every single block in the system is encrypted, and that includes any temporary spills to disk during queries and any backed up blocks. And then we use a multi-layered encryption mechanism to lower the cost of key rotation, and we plan to add support for customer on-premise hardware security modules in the near future. There's no direct access to the compute nodes. They're completely locked inside a private security group, and you can run your entire cluster inside the Amazon Virtual Private Cloud, or VPC, and this is a logically isolated section of the AWS cloud where you control the networking access to the outside world, and you can connect it via VPN to your existing infrastructure. Another aspect of providing a managed service is that we try and make operations and monitoring and fault tolerance something that you can take for granted. And so to deliver data durability, anytime data is loaded in the cluster, we synchronously replicate it to other drives on different nodes so we can transparently handle drive failures. If you think about it, with 108 extra large nodes, at 24 spindles per node, you've got 2,400 spinning drives. You have to plan for drive failure. And on the nodes, actually, we reserve twice the amount of space as is available to customers to deal with replication and rebuilding of failed drives, and that does not come out of your quota of storage. And then in addition to the synchronous replication within the cluster, we're continuously and incrementally and automatically backing up your cluster to Amazon S3. And this is designed for 11 nines of durability. And so with replication and continuous backup, what you have is a highly, highly durable system. And then those backups we call them snapshots. You can pick their retention period. You can clone a cluster from one of your snapshots, stand it up for an hour, and then tear it down when you're done. And we see customers do this, for example, if they want to prototype or test out some new models rather than running it on a production system. They can spin up a completely identical system in minutes, do what they need to do, and then roll it out into production and tear down the development system. So a lot of things become possible in the cloud that are much harder to do. And I think these are some of the drivers behind the excitement that we've seen in the market around Redshift. The other aspect is that we continuously monitor components and nodes in the system. So in the event of any failures, we can take action. If a node fails, we'll automatically replace it and bring your cluster back up and begin streaming data back onto it. and then the snapshots themselves can be restored into any availability zone within a region, and an availability zone is a completely isolated data center with its own heat, power, cooling, and network, so you can essentially deal with any outages by restoring a new cluster in minutes. And because Redshift uses standard Postgres drivers over JDBC and ODBC, you can use it with your existing analysis tools. And so the companies you see here are a subset of those that have put Redshift through their own internal certification, though we have customers using a broad array of tools. Really anything that can speak to a Postgres database can speak to Amazon Redshift. And our goal with Redshift was really to design a fast, cheap, and easy-to-use data warehouse that would be the central repository for data generated in a range of different areas. And so in any organization, you'll have transactional and OLTP systems. You might have unstructured data being processed on HDFS clusters or in Amazon Elastic MapReduce. You may have log files that are being generated and stored elsewhere and processed. You may have a NoSQL store. You'll have systems, disparate systems in your own data centers. And because of the desire to integrate all of this data into one place, that's really why we're so excited about our relationship with Informatica and the connector, as it provides you with an easy way to connect all of these at scale. And so with that, I will turn it back over to Darren, and thank you.
Thank you, Rahul. That was an amazing overview, really deep into what you've done, and congratulations on really the success you've seen in a short time. And I will say, some of the technical questions we're getting are really, show that what you've been taking us through is of interest to today's audience. So before we answer some of those questions, we want to now switch gears and really dive into Informatica's role in a Redshift implementation. So I want to spend a minute just to walk you through. Many of you on today's call are familiar with PowerCenter. You're familiar with the Informatica core technology. And I want to just walk you through how Informatica Cloud operates and how it shares the same engine which allows you to map once and deploy anywhere between Cloud and PowerCenter. Nick in his demo will actually also dive into this as well in a fair amount of detail. So the first thing you need to know about Informatica Cloud is you can go and sign up on the web just like you would be signing up online for Amazon Redshift, informaticacloud.com. Once you register, you're asked to install a very small download, which is what we call our secure agent. That is typically going to sit behind the firewall, but we see a lot of our customers hosting the agent as well. That agent is really what's going to be doing the heavy lifting, what Nick is going to be taking you through, moving the data to and from sources and targets, and in our case today, moving data in and out of Redshift. Now, the important thing to note is really that it is a dotted line from the web and our multi-tenant metadata repository to the agent. So no data lives in the cloud with Informatica. It's the agent that's doing the movement and the transformation of the data between your sources and targets. And again, Nick will be walking you through what that looks like. So I wanted to explain architecturally how Informatica Cloud operates. And really a key value we're seeing from our core customers, many of you on today's call, is that you can reuse your work. You can build mappings in the cloud, bring them down to an on-premise environment. You can build them on-premise, move them up to the cloud. This concept of map once, deploy anywhere is a key element of our underlying engine, our virtual data machine, which we call Vibe. So with that, I'm going to hand it over to Nick to really show you what we're going to do today and then walk you through a demonstration, and we're going to leave plenty of time for some questions at the end of the presentation. Over to you, Nick.
Thanks. So the goal of today's demonstration is to show you how easy it is to move data from your on-premise and cloud applications into Redshift. And before I do the actual demonstrations, I'd like to walk you through a little bit of what's going to be going on sort of behind the scenes when we're going to launch the task from the user interface. So the first thing we do is we're going to log into Informatica Cloud, and once we launch our task, the mappings and the information in the task will be downloaded to the secure agent behind the firewall. At that point, the secure agent is going to go retrieve account information from the local database. And in this case, what we'd like to do is we want to move our on-premise account account information into Redshift for business intelligence purposes to do some reporting. And in order to get more accurate information, we're going to go into a customer relationship management application. In this case, it's going to be Salesforce up in the cloud, and we're going to go obtain the service level agreement level, and then combine that with the information coming out of the Microsoft SQL Server, and then upload that into Redshift. At this point, we grab all the data, we put it into a flat file locally, we compress it, and then we upload it into S3. And this is one of the ways that you can move data into Redshift. And so we move the data using S3. Once we've transferred it into S3, we tell Amazon Redshift to load the data from S3, and then the data gets loaded. Okay, so now we're going to move into the demonstration of how all this happens. So first, you go to Informatica Cloud, and I want to point out here that it's very easy to sign up for that 30-day free trial. And within that free trial, you can also test out the Redshift adapters, connector, and other connectors that you can work with. So first, let's log in. And as I mentioned, you can go take a look at the long list of connectors that we have. And in this case, I've already ordered the free trial of Amazon Redshift, but we have a number of other connectors that you can work with. So there's a long list of them here, from Dynamics to Workday, Salesforce, etc. So the first thing we're going to do now is we're going to go create our synchronization task. And in this case, we use a wizard-based approach to make it very easy to move data from one place to another. And in this case, we're going to use a wizard to move the data into Redshift. So first we'll give our task a name, and then we're going to choose the kind of task that we want to create. So with our Redshift support, we can do either an insert operation, where you add new rows to the data, or what we call an upsert, which is we can either update an existing row of information or insert a new one. And in this case, I want to do this because I'd like to run this task on a scheduled basis so that I can keep my account information that I'm using for my reporting up to date. So the second step in this wizard is to choose a source connector. Now here we see all the list of connectors that I have available, but in this particular case, I'm going to work with Microsoft SQL. Once we connect to a table or to a database, it's going to bring back the list of objects or tables that are available for us to connect to. In this case, I only have one, and that's my on-premise account information. Informatica Cloud also gives us a preview of the data that's in that database. I want you to pay attention here to the total number of columns. So it's not a large data set, but at the end of this demonstration, you'll see how we're not going to move all of the data into Redshift because some of it is incomplete. Our third step is to choose a destination. Now in this case, we're going to choose Amazon Redshift. And let me just interrupt setting up this task briefly here to explain a little bit what it takes to set up your connection. So the connector needs two pieces of information from Amazon Web Services. You're going to need your Redshift connection information as well as your S3 bucket connection information. So as Rahul mentioned earlier, Amazon has made it very, very easy to work and set up and launch these clusters. So here I have a single cluster running, and I'm going to go take a look at all the information that's available here. And as Rahul mentioned, it's very simple to resize your cluster if you need to make it bigger because you have more data or you need to have more performance or more nodes to it. So the important thing here is I need my database name, I need the JDBC URL, which is provided here, and I can just copy and paste it. And then once I bring those in, the other piece of information I'm going to need to be able to connect with the S3 bucket is I need to go to my security credentials and go get my access key and my secret access key. And this is available here under the security credentials dashboard under access keys. Of course, I'm not going to show them to you today. All right. So once we've entered all this information, and you need to also enter the cluster node type and the number of nodes in the cluster, we can test this connection. And here we can see that everything is working just fine. So now we're ready to proceed. At this point, we query Redshift to see what's available as a target object. Again, I only have one object available here, the account. And it is an empty table because I'm starting from scratch. As part part of the process of moving data into Redshift, we can apply filters to the source data. In this case, what I'd like to do is I don't want to bring in some of the accounts that are missing information. So I know that the data folks who enter some of this information, sometimes they leave out the state information, and I don't want those accounts. So I only want those that actually have information in them. So this is going to ignore all those records where the billing state is missing. The next step here is to do our actual field mapping. And we make this very simple for you. So you simply drag the fields over in order to do the mapping. In this case, I'm going to drag over all of the missing fields. And I want to point out that if you drag a field again into one of the existing mappings, it will actually do a concatenation automatically. Now in this case, I'm not interested in doing that, so I'll just use the single state field. Okay, if you remember from the slide that I showed you earlier, one of the things that we want to do is we want to enrich this data with some additional information from our CRM system, which is Salesforce. So here I'm going to do a lookup into Salesforce to get that information. So once again, I have access to all the connectors that you saw on that page where I showed you all our connectors. And here I choose Salesforce, and I've already configured my information for Salesforce. And once we choose the data source that we want to do a lookup in, it queries it for all the objects available. Now I know that I can get my service level agreement out of the account record, so that's what I'm going to use. We then choose how we want to match the records in both sources. So in this case, I'm going to choose ID from my on-premise database and account ID from Salesforce. The last piece is to pick what is it that I want to be returned from part of this lookup. And here I want the service level agreement, the SLA. Lastly, I'm going to bring up the expression panel where you can create expressions to transform the data or add additional information as you're moving data into a target. Now our existing PowerCenter users will recognize that we have all of the functions that are available in PowerCenter available up in the cloud. So here I'm going to choose a timestamp because I'd like to know when was my record last updated. So let's review what we did here. We did all our mappings. We inserted a lookup to go get the service level agreement and added a timestamp to timestamp the accounts we know when it was last updated. Finally, in the sixth part of our wizard, we have the option of creating a schedule. Now in today's demo, I'm just going to run it, but just to show you, it's very simple to create these schedules. We need some additional information here for making the connection to S3.
A quick question came
Sure.
in. We're going to hold most of the questions, but on the scheduling front, can you just talk about the frequency of scheduling? A question came in about, can I have this run on a regular basis? What are my options there in terms of scheduling?
Sure. I'll just walk you through it so you can schedule it every minute, every hour, daily, weekly, monthly.
Great. And some people ask us sometimes, can they use their existing scheduling tools? And that's an option because Informatica Cloud does have a REST API. So you can actually use your existing scheduling tools to kick off Informatica Cloud tasks.
That's correct. All right, so
And,
here, yes, go ahead, Rahul.
I just wanted to point out one of the really cool things about the connector, and that's this the batch size. So I talked about loading Redshift from S3 in parallel. So what we recommend is that you have multiple input files per table so that each core on the Redshift cluster can load data in parallel simultaneously, so you can maximize your load throughput from S3. And it's great to see that capability built in here, so you can choose your file splitting size from the connector itself.
Thanks, Rahul. And at the end of this demonstration, I'll show you some of the best practices that you can follow to leverage that parallel loading capability. So one of the other things I need to do here, in order for the agent to upload the data to S3, it needs a local folder or some area to be able to temporarily store files to upload them. So here I've provided a local shared local folder to put that information in. I'm not going to change the batch size because I only have 15 records. And in addition, you can choose to have all the rows that were successfully transferred or those that failed put into delimited files for you to review later. But I'm not going to do that here. So now we're done, and we've created our task, and we're ready to run it. So we're going to save this, and once we run it, Informatica Cloud will take you to the dashboard to monitor your task as it's running. Now this is going to take a little bit of time to run, so in the meantime, I'm going to answer one of the questions that a lot of our existing PowerCenter customers have, which is, can we reuse our existing mappings in the Informatica Cloud? And the answer is yes. So if we go to our PowerCenter task page, we can create a PowerCenter task where we reuse an XML file coming from PowerCenter. And let me show you an example of that. So if we look here in my PowerCenter designer, we can see the mappings that I have already set up here. And then we can go to the repository manager to take our workflow that uses those mappings and export it into an XML file. So I'm going to do that. And then I can go back into Informatica Cloud and go grab that XML file to be able to reuse those mappings. So let me do that. So here's my workflow mapping. Let me just give this a name. And notice at the bottom here, it's picked up the target and the source definitions as well as the table that we're going to be working with. One of the things that I have to do is, of course, indicate where we're pulling this from. It happens to be coming from the same table, so I'm going to choose my Microsoft SQL Server connection, and then you must assign it an agent. At this point, we're done. We can save it and we can run it. Now, I'm not going to cover that today, but this is how you can reuse your existing PowerCenter mappings.
And that's really powerful, that ability to map once, deploy anywhere. The same is also then true on mappings that you built today in your demonstration. You can bring those down into PowerCenter, open them up, and do further work on those.
That's right. So let's go take a look now and see if our task is completed. So it looks like we've successfully transferred our rows. So now to go validate that, I'm going to use the database query tool to go take a look at the data. So we can see here now that the database actually has some information in it. So now we're connecting to Redshift using DB Visualizer and using a JDBC driver to connect to Redshift. Let's take a look at our data now. So remember when we first set up our task, we said we don't want any data that doesn't have state information in it. And in this case, we filtered those out because we only have 11 out of the 15 records. We also said, let's go get the service level agreement from Salesforce. So here we grab, for example, for the first record, the platinum level for that particular account. So in literally in about 10 minutes, we grabbed data from a source, we enriched it with some information, we filtered, we added some transformation, and then we moved it into Redshift. Okay. So now we're going to review, again, what happened while we were walking through all this. So the first step is the agent, once you've created your task, the agent downloads the mappings and the task information locally. It then grabs the data from the source, applies any filters to it that it needs to, and then if you have any lookup information in your mappings or any additional transformation, it will apply those. For loading into Redshift, we then stage the data locally, compress it, load it up into S3, and finally we tell Redshift to transfer the data from Amazon. And if you're loading in multiple batches and you have multiple nodes configured for your Redshift cluster, we will load those in parallel. So let's look at a couple of best practices to remember here. So one of them is that your S3 bucket has to be in the same region as your cluster. And this is, all of these best practices were well documented on Amazon's documentation for Amazon Web Services. Excellent documentation. One other thing to mention is once we've transferred the data into the S3 bucket and the task is completed and all the data has been moved over, we will delete those files. So you don't have to worry about them hanging around and charging you additional money. Okay. Earlier, Rahul explained a little bit about how we can leverage the parallel processing capabilities. So one of the things that you want to do when you choose a batch size is you want to match it to the number of slices that you have in your cluster. So in my case, I only had a single Excel node, so I only had 2 slices available to me. But if I'd had a 2-node cluster and 40,000 rows of data, I would have chosen a batch size of 10,000 to be able to load in parallel in 4 batches. This way we can leverage the parallel processing capabilities that Amazon gives us. Okay. At this point, I'm going to hand it back over to you, Darren.
Awesome. Great overview. And we do want to also talk a bit about the, you went into in your demonstration a little bit about the PowerCenter mappings. And we do have a few customer questions about that. Do you want to address that here on the Mappings in Informatica Cloud slide?
Sure. So, this is, again, as I mentioned earlier, this comes up quite a bit. So there's really two ways that you can leverage what you have currently in PowerCenter. So the first option is what I showed you, where if you wanted to, you could move your mappings over into Informatica Cloud. But you could also, if you wanted to, simply stage the data locally and then create an Informatica Cloud task to move that data into Redshift from that staged database. And the nice thing is that you can, even though once you've created the task in Informatica Cloud, you can control this from PowerCenter. So really it's just a question of enabling that connection to Redshift to be able to transfer the data. So really you have two options here to be able to leverage your existing investment in PowerCenter.
Fantastic. All right. So just to summarize some of the Informatica Cloud capabilities, I think you'll find some of the messaging is quite similar to what Rahul took us through when he really walked us through a detailed overview of Redshift. We've talked about this benefit of being able to map once and deploy anywhere with the Vibe architecture of Informatica. But really, in terms of a cloud-based offering, this ability to rapidly connect and deploy your integration, similar to how you're rapidly now able to deploy the Redshift from a data warehousing or big data perspective. Very similar views on what we are trying to set out to achieve here. The other, of course, is this ability to do fairly advanced integrations in a much easier way than has historically been possible. And then there's been a few questions about batch and real time, and that's really a key for Informatica, being able to address a broad range of use cases. And you heard Rahul take you through some of the use cases around Redshift. So more details there on informaticacloud.com. Before we open it up, we clearly, as we talked about, you can get started with Informatica Cloud from our website, and just as easily you can get started with Redshift on the Amazon site. And I know many of you are already working with Redshift and are now looking at how do we move data in and out of it. So details here on a few different resources, but let's dive into some questions, and I've put up all of the presenters here and our contact information. You can reach us certainly through Twitter, but also through, if you'd like to, directly through some of our various email addresses, which we'd be happy to share with you after the presentation. So the first question I wanted to bring it back to you, Rahul. There were some questions that came in as you were taking us through Redshift. One was around performance. How does performance vary as you add nodes to Redshift?
Absolutely. Thanks, Darren. And so one of the benefits of Redshift as an MPP system is that there's near linear increases in performance as you add nodes to the system. And so when you resize, Redshift will automatically redistribute your data across the new node count in the cluster. And so if you think about it, if you had 100 terabytes before and then you double the number of nodes, you still have the same amount of data, but each node now has half as much data as before, but still has the same number of spindles, same amount of RAM, same number of cores acting on it. And so you're able to process data in parallel that much faster. And that's really been behind a lot of our philosophy with Redshift, is we wanted to make all operations as parallel as possible so that when you add nodes to the system, your query performance goes up, your load throughput goes up, and that's why resize has been a point of emphasis for us. And so you can add nodes both to increase performance as well as to get more storage.
Okay, great. A couple questions came up on the pricing side of things, or subscription. So when a user subscribes to Redshift, do they also need to subscribe separately to S3?
So when you create an AWS account, you're effectively subscribed to all of the services, and then you're able to pick and choose as you need. And so once you start a Redshift cluster running, you will be charged for your Redshift usage. If you put data onto S3, for example, for loading it into Redshift, you'll be charged for your S3 usage. And again, everything's billed hourly. So if you had your data up there, loaded it into Redshift, and then deleted it from S3, you would only be charged for the amount of time that it was on. And then once it's in Redshift, your charges are really just the number of nodes and what's running. We give you free backup storage up to the amount of active data warehouse space. So what that means is if you have a 10 terabyte cluster, you'll get 10 terabytes of free backup storage on S3. And because it's incremental, we try and be as efficient as possible about how we use that. And then once you exceed the 10 terabyte or whatever it is that you have provisioned limit, you'd be billed at S3 rates for that storage. So it's all itemized, very granular, so that you can control and keep an eye on it.
Okay, great. There's a few more coming in for you, Rahul. I'll come back to you in a second. I want to bring you back in here, Nick. In the staging directory, is the local folder on the same server that the agent is located? Any best practices there?
The general best practice rule for the agent is that it needs to be able to see whatever folder it is that you're pointing to. So it can be something that, a location that's on your network. So it doesn't technically have to be exactly on the server where your agent is running, but of course it has to be a folder that's accessible to the agent.
Okay, great. And another one that might be for either of you, will the data load from S3 into Redshift be part of the 15 query limit that Redshift seems to have? Maybe you want to take that one, Rahul?
Sure. So what you're referring to is there's a concurrent query limit on Redshift. So there's a 15 slot limit, so you can have 15 queries executing in parallel simultaneously. However, anything that comes in would be queued. And so, yes, essentially data loading via copy is a SQL statement and therefore a query. And we do provide there's automatic queuing built into the system, and then there's also the ability to set up workload management for setting up queues for long jobs and short jobs, so you can ensure that your query throughput remains high. And I think the concurrency limit is really a reflection of Redshift's design as an enterprise data warehouse and an analytics system rather than a high concurrency transactional system.
Good, great. So a couple of questions have come in on the Informatica Cloud architecture, specifically about the agent, and we talked a bit about one example of where to run the agent. It's really important to understand that the Informatica Cloud really hosts metadata. We don't actually host any of your transactional or database information. So it's really what you use to move the data, and the agent is typically living on-premise. A lot of our use cases today happen to be cloud to ground or ground to cloud. We are increasingly seeing customers do cloud to cloud. So you'll see new hosted agent options from us down the road. We do have many of our customers that do decide to run the agent on an Amazon S3 environment. So that's certainly a deployment option as well. But it is important, and I did share a link in the chat panel about the security and architecture of Informatica Cloud. That's been really key for us, is that agent, and really the fact that we don't host your data. We are a cloud integration service. So let's get back to a couple other questions here. There was a question here, Rahul, about the leader node, and making sure that that doesn't become a bottleneck in an MPP architecture, even though you're adding additional nodes. Anything you want to comment around, the architecture and MPP behind Redshift?
Yeah. Absolutely, and I think it's a common question, but the fact is the leader node actually does very, very little work. Essentially, it's just an endpoint and an orchestrator, and so query execution is actually handled by all of the compute nodes, and so it doesn't become a performance bottleneck because it doesn't participate in query execution. So when you actually issue a query, the optimizer generates a query plan that actually is then used to generate C++, which is compiled and then pushed down to each of the compute nodes where it's actually executed against the data that lives in that node. And then the results are brought back up and collated. And so you'll see in any sort of performance monitoring curves that you look at in the console that your leader node is doing barely any work at all, while your compute nodes are, we try to max them out on every single query to maximize performance.
Okay, great. Great. There was a question about, in Nick's demo, you connected to Salesforce, and I think there was some comment there that they thought you didn't need to use Salesforce. That's not actually the case at all. We have a very deep set of connectivity options and capabilities for Salesforce customers. So you can go to informaticacloud.com/Salesforce and see the number of different ways we interact with that cloud application and platform. In fact, Informatica Cloud has been recognized 5 years in a row as the top data integration solution provider for Salesforce customers. So another one for you, and we've got a couple more minutes, and questions are pouring in, so this is great. Clearly, a hot topic, and everybody's going beyond just considering it and now looking at some real deployment questions. So Rahul, is there a support plan for AWS EMR clusters? Put you on the spot for a roadmap question.
So we don't discuss specifics in our roadmap today. You can actually, because S3 is effectively a Chicago O'Hare in the AWS cloud, all services speak to it, and so you can process data in EMR, put it onto S3, and then parallel load it into Redshift. I think we are, we're always looking for ways to make those integrations within AWS easier, and so appreciate the feedback on that, and it's a use case we see a lot, and we definitely pay attention to our customer feedback.
Okay, great. Let me ask you one that you probably get all the time, and I think we've shown you in our demonstration how Informatica can help here. But the question is, how easy is it to migrate from my existing system to Amazon Redshift?
It's a great question, and we do get that often. And our customers have found it relatively straightforward. And the reason is that Redshift is it's a relational data warehouse. So we speak Postgres over the wire. You'll use familiar SQL to generate your schemas. We support really any schema that you have. So we have customers running flat, white, and denormalized, or people running third normal form or stars and snowflakes, and you can bring those in largely as is. The only decisions you have to make that are slightly different are Redshift as a columnar system doesn't need or support indexes. However, you do need to think about how your data is sorted, so choosing a sort key, and how it's distributed, and that's choosing a distribution key. So there's some elements to table design there that we lay out in our documentation. And depending on how your queries are set up, for example, if you're using particular functions unique to things like PL SQL, you might have to do some query rewriting. But in general, migration is a straightforward aspect. And then, the other goal with Redshift was to work with your existing tooling. And so if you have something like, if you have PowerCenter, you could bring that in and use it as part of your infrastructure, but just with Redshift as a target instead. So generally a fairly straightforward operation.
Okay, fantastic. Let's take one more question here, and then maybe we can just put some closing remarks out there from each of the presenters. So one question, again, is kind of a deep one for you, Rahul, about snapshots. What would be a typical time to take snapshots from Redshift? If I plan not to use the Redshift temporarily and spin it on demand, I'm not sure if I understand that complete question, but anything you want to comment on snapshots?
Absolutely, and actually that pattern is one that is fairly common when customers are doing their proofs of concept. We'll see folks run their clusters Monday to Friday, delete them and save a snapshot over the weekend, and then spin them up again on Monday and proceed with their testing. Obviously, production workloads tend to be 24/7, but for POCs, it's a great way to optimize your costs. And so creating snapshots, it's automatic and incremental. So the first snapshot after a large load may take some time, but after that, it only captures the deltas. And we keep track of the state so we can recreate the entire cluster at any point. And when you're restoring from a snapshot, we actually invested quite a bit of effort here in a feature called Streaming Restore. And so when you choose to restore a cluster from a snapshot, we provision the cluster, load the system metadata onto it, and so that's a 15 to 20 minute process. And as soon as that's done, your cluster is available for querying, and then we will stream in data from S3, bringing back the most frequently used data first. When we found that, for example, while we may have 3 years of data in our data warehouse, most queries we run will be looking at the last week or the last month. So because of that temporal locality, the streaming restore means that once just 1 to 5% of the data is back, most of the customers' queries run normally. And then we will just prioritize and effectively fault in data just to get you operational and available as quickly as possible.
Fantastic. So Rahul, why don't any final thoughts for our attendees? Many folks, as you can tell, are pretty steeped in data warehousing. Any resources you'd want to point to or suggested next steps?
Absolutely, and I think we've designed Redshift to be really easy to test and to create a proof of concept with, and so welcome you to spin up a cluster. I'm easily found on Twitter and by email. We'll be happy to field any questions or set up one-to-one discussions. And then the other area to go check is our documentation and best practices, where we lay out exactly how to get the most out of Redshift and where we differ from systems that you might be familiar with.
Awesome. Thanks for that. And Nick, you're a long-time business intelligence guy with a lot of experience in database world. Any final thoughts from you as we dive into the Redshift connector and next steps for our attendees today?
Yeah, I mean, one of the things I'd like to mention is that because of the architecture of Redshift, it makes it really easy for setting up databases for analysis purposes, because you don't have to worry about being an expert DBA to configure for the utmost performance. So really, it's just a question of picking the right data, moving it in there, and then following some of the best practices that Amazon recommends. But you don't have to worry about indexes or anything of that nature. And it really simplifies that ability to make analysis very easy on all your existing enterprise data.
Great. And then in terms of, there's a lot of questions coming from Informatica Cloud. You're active on our community. Any information there you'd want to share?
Sure. Please, I realize there's a lot of questions, and unfortunately we can't get to them all, but we're more than happy to answer them on the Informatica community website. There's a cloud subsection. Please go post your questions there. And also, feel free to go try it out. Go on our website, sign up for the free trial, sign up for any of the connectors you want to work with. In particular, the Redshift one is available there today. There's also a number of videos that can explain how to set up the tasks, everything that I walked you through today. It's very straightforward. So please, I encourage you to go try it out. That's the best way to find out the value of how easy it is to do this.
Okay, well, fantastic. With that, I think we'll wrap up and end today's presentation. Rahul Pathak, I really want to thank you again for just a fantastic, deep overview of an amazing new product line. So thank you for your participation, and we look forward to working with you. Nicholas, thank you for a great demo, and we look forward to hearing from all of you and helping you really get up and running with more and more of your cloud-based business intelligence and big data and cloud integration use cases.
Thanks, everyone.
Thank you.